Okay, so hello. Today we are talking chemical nomenclature, and specifically within chemical nomenclature, metals are an important topic in being able to name compounds. Of course, when we think of metals, we usually think of solids at room temperature that are good conductors of heat and electricity, that are malleable and ductile, which means that they can be pulled into sheets or into wires. Um, and those are relatively true. Of course, mercury is a liquid at room temperature, and there is some variety in metals. When we are thinking about them in terms of naming compounds in chemical nomenclature, what we want to know is if it's a metal and whether we know its charge. So looking at the periodic table here in yellow are the metals. We have on the left the group 1, the alkali metals, and the alkaline earth metals in group 2. Here between the S and P block of the periodic tables, we transition with the transition metals that go from scandium to zinc. Here, this block are the transition metals. In this two missing slots here go the lanthanide and actinide series, this F block, which we also call the inner transition metals because they go inside the transition metals. And then over here beyond the transition metals, we have the post-transition metals. And so those are all of the metals on the periodic table. The elements that we know the charge they're going to form, hydrogen forms a 1 plus cation along with the alkali metals, lithium, sodium, potassium, rubidium, cesium, and silver all form a 1 plus cation. We can count on that. The alkaline earth metals, magnesium through barium, all form a 2 plus cation. They lose 2 electrons. So do cadmium and zinc in the transition metals, also always form a 2 plus cation. Aluminum in group 13 always forms 3 plus. We can count on that when we see that aluminum forms a compound. We can trust it will lose 3 electrons. The rest of the metals, we cannot be sure what cation they're going to form. They can form more than one type of cation by losing more than one amount of electrons. Sometimes they might form 2 plus cations, 3 plus, 4 plus, etc. And so to be able to determine what the charge of the mystery metal cation is, we often have to know something about the counter charge, the anion, the negative charge. And we know that when hydrogen takes the place of an anion, it, along with the halogens in group 17, fluorine, chlorine, bromine, and iodine, they all gain 1 electron and form a -1 charged anion. The elements oxygen and sulfur in group 16 or 6A gain 2 electrons and form anions with a 2- charge, and nitrogen gains 3 electrons and forms a -3 charged anion. And we can use that information if we know that there are 2 chlorines with magnesium, that magnesium is 2 plus as an alkaline metal. We know that will always be true. But for something like iron, which is a transition metal, we don't necessarily know what charge the cation is because the cation can be multiple charges. And so in this case, we can see because there's 3 2- oxygens between 2 iron elements that each of them must be 3 plus, so that the 3 plus equals, I'm sorry, the 6 plus equals the 6- here, and the charges sum to 0. So we use our knowledge about the charge of the anion to be able to deduce what the charge of the cation is, the metal, when we otherwise can't be sure of how many electrons it's going to lose in forming a compound. So that's the information that I want you to know about metals. I moved through it quickly, but using the periodic table and being able to identify if it's a metal and if it is a metal, whether or not we know predictably what charge it's going to form is a necessary skill that I think you're going to want to practice so that you can be proficient in your nomenclature in chemistry.